Hi guys, welcome back to part 2 of lesson 5.1, operations with functions. Today we're going to do multiplying. We're going to pick up where we left off yesterday, which is page 75 of your Springboard book. And again, make sure you have a pen or pencil and a calculator nearby. So let's go ahead and get started. Continuing on with Jim and green grass guaranteed. It says here, Jim has been asked to make a bid for installing the shrubs around a new office building. In the bid, he needs to include the number of shrubs he can install in an 8-hour day, the cost per shrub, including installation, and the total cost of his services for an 8-hour day. Okay, so 13a says, write a function n of h to represent the number of shrubs Jim can install in an 8-hour day when it takes him h hours to install one shrub. Okay, so again, we are going to kind of be coming up with a function here. And in this case, think about it. If you were trying to figure out, okay, I have 8 hours and I can do this in however many hours. Okay, so let's say you knew you could put in one shrub in 2 hours, right? So you would do 8 divided by 2 hours to figure out how many shrubs you could put in a day, which would be 4, right? So in this case, we know n of h has to be 8 divided by h because we don't know how many hours it takes him to install one shrub. Okay, I was just doing that example of using 2. Okay. Then part B says, what are the restrictions on the domain of n of h? Explain. So what value can h not be in this case? Go ahead and answer that. And hopefully you said 0. H cannot be 0. So we could write that as h must be greater than 0. And remember, that's because it's in the denominator and we cannot divide by 0. It makes the function undefined. It also doesn't make sense in this case to have h be a negative. We can't have negative hours. Okay, so h is greater than 0. That's what we're going to say for our restriction here. Okay. All right, then 14 says, Jim will charge $16 for each shrub. He will also charge $65 per hour for installation services. Write a function c of h to represent the amount Jim will charge for a shrub that takes h hours to install. Okay, so we still don't know hours, but we know he's going to charge $65 per hour, so 65h. Plus, he's also going to charge $16 for the shrub, so plus a flat rate or a flat fee of 16. Okay. All right, moving right along. It says the total cost of Jim's services for an 8-hour day is equal to the number of shrubs he can install times the charge for each shrub. Okay, so again, we have this nice little writing math tip for the notation, but it says here, in order to find the total cost, we are going to multiply that n of h function that we came up with in 13a by the c of h function that we came up with in 14, okay? Then we're going to simplify the function rule. So this is going to look like 8 over h times 65h plus 16. Okay, well, first of all, when we kind of distribute this in, that's all we're doing is multiplying that in, okay? So 8h times 65h, the h's are actually going to cancel. So it's really just 65 times 8, which is 520. Plus 8 over h times a positive 16. So we're going to have to multiply the numerators there, which would be 16 times 8, which is 128. And then the h won't cancel in this case, so it's still written as over h. So this right here is your simplified function to figure out Jim's total cost of services. Okay? And again, the restrictions on the domain here still have to be h is greater than 0 because we still have the h in the denominator here. Okay? Cool. Moving right along. Here it says Jim estimates that it will take him about 0.5 or half an hour to install each shrub. Use the functions n of h, c of h, and n times c of h to determine the following rules. So the number of shrubs Jim can install in an 8-hour day. Well, that was our n of h function. So let's plug in 0.5. Whoops. Whoa, sorry about that. Let's go ahead and move this. All right. So n of 0.5 equals 8 over 0.5, which means that he will be able to, if you actually divided that, it would mean 16 shrubs. That's how many he can install in an 8-hour day. Okay. Then the cost per shrub, that's going to be our C of H function. So C times 0.5. And then remember that was 65 H. So 65 times 0.5 plus 16. And that was 48.50, or that will equal 48.50. Okay. So the total cost then, we would have to do that 16 shrubs times 48.50. Okay, so grab your calculator for that. 16 times 48.50 is going to give you $776. So we would multiply that and you would get 776. Okay. Now, again, we just did that in 3 steps. But if we were to just use that n times c of h function, which is was the 520 plus 128 over 0.5. If you just do that all in one step, that multiplied function that we came up with, you're going to get the same thing, $776. Okay. So this way, again, is a little bit quicker when you use that multiplied function. All right. So let's look at a couple more examples. We're going to skip over the rest of this page. This moves into division here. And then we're going to jump into 21 on page 77, parts A and B, because those, if you look at the notation, those are both asking for multiplication. Okay. All right, so let's take a look. This first one says f of x equals 2x, g of x equals x plus 3, and h of x equals 2x plus 6. And it's asking us to multiply f times g. Okay, so f of x is 2x, and g of x is x plus 3. So if we want to multiply this, all we're going to do is distribute that in. So that's one way to multiply. So 2x times x, be careful with this. 2x times x is a 2x squared. Remember, we're not multiplying, or sorry, we're not adding or subtracting anymore. Now we're multiplying, okay? Then 2x times 3 is a 6x. Okay. And so that would be our multiplied version of f times g. Okay. All right. Then this next one, I'm going to show you guys 2 different ways we can do this, but this is g times h of x. So g is x plus 3. And then times h of x is 2x plus 6. Okay. Now, here's what I'm going to do. I'm going to end up writing these in parentheses because we're multiplying them. Okay, so if you want, you could put like the little multiply there, but we're doing x plus 3 times 2x plus 6. And there's 2 ways we can do this. The first way being your FOIL method. Hopefully we remember this, okay? So FOIL means first you're going to take the first. So first times first, x times 2x is 2x squared. Then you're going to take your outers. Outer, outer. X times 6 is 6x. Then you're going to take your inners. Inner, inner. 3 times 2x is 6x. Then you're going to take your lasts. Whoops. 3 times 6 is 18. Then you're going to combine like terms to simplify. So we've got some like terms right here. So your final answer would be 2x squared. 6x plus 6x is 12x. And then plus 18. And that would be your final answer. Okay. All right. Now I told you I would show you another way. So your other way is box method. So if I'm doing box method, I would put the x plus 3 on the top of my box. Whoops. And I would put the 2x plus 6 on the side. And I would multiply what goes in each little box. So 2x times x is 2x squared. 2x times 3 is 6x. Notice I'm doing the same thing, really. 6 times x is 6x. And 6 times 3 is 18. Again, I would combine like terms here, and I would get 2x squared plus 12x plus 18. So either method works every time. This method here, the box method, is a little bit more visual. This FOIL method here, you just have to remember to follow first, outer, inner, last. Okay, but that is how we go ahead and multiply two functions. All right, we'll do more practice with this tomorrow on the Zoom. See you guys later. Have a good one.